I am based in New Jersey in the United States, living right outside of New York City. I am currently, well, I have for my entire 30 plus year career been working for the same big pharma company. The company is Merck, as we will be discussing some of the products that I've been working on, so you will be able to figure it out. I am a chemical engineer by degree and by training. So I have a bachelor's of science in chemical engineering from Lehigh University. A shout out to Sherry and Arlene, two of my sorority sisters, who I see are online supporting me. Thank you. And then I have a master's of science in chemical engineering from the University of Virginia. And right after that was when I joined Merck. And I've been working with the same company at various different sites in many different roles for about the last 30 years. And I am just thrilled to be able to share some of my experiences with you, share some advice, things I've learned along the way. So hopefully it can keep you from making some of the same mistakes that I have made, if you want to call them mistakes, in my career, learn things a little sooner and answer any questions you might have.
Joni, now you worked as a chemical engineer on some really, really interesting drug projects, haven't you? You've worked on the AIDS drug, drugs for Parkinson's, oncology drugs, even gunshot wound drugs. Do you want to tell us a little bit about those and how you got into that?
Right. So, Merck is a pharmaceutical company, and in joining a pharmaceutical company, that's what you do. You make pharmaceuticals. Most of my career, I would say the vast majority has been spent actually making the powder that gets compressed into the tablets, not actually making the tablets themselves. The drugs that I've had the opportunity to work on and help improve the lives and health of many people in the US and worldwide. The first drug I worked on is still on the market. It is called Premaxin. It is a sterile drug, means it is injected into your veins. It is a combination of two drugs, one called cilastatin and one called imipenem. And that, as you referred to, Dion, is the drug of choice in emergency rooms for gunshot wounds because it is a large spectrum antibiotic. So I thought that was really cool. In 1993, 94, I was assigned to a team to design a plant for a drug, which we didn't know what it was called. It's now called Crixivan. It was an AIDS drug. It was highly top secret. We couldn't even say that we were working on an AIDS therapy at the time because there was so much political sensitivity around the disease. And that drug has pretty much caused AIDS to become a chronic condition versus a death sentence. 1989, you got AIDS, you're dead. Now, if you get AIDS, it is managed through a variety of antiviral drugs. So, and this one was the first drug that actually had that impact on the disease. And in 2012, I was on a team supporting the actual release of the finished drug that people take for what was known as anti-PD-1. MK3475 was the Merck trade handle for it, and it is now known as Keytruda or pembrolizumab, which is an immunotherapy. It's like it was the new greatest oncology breakthrough in the late teens, and there are many types of immunotherapies for oncology on the market now, but that was the first.
How did you get into chemical engineering? What was your education?
I didn't know what a chemical engineer did either. So let's everybody join the club. We'll all hold hands and sing Kumbaya, because I don't think anybody really knows what an engineer does. And that's because engineers can do a lot of different things, and that's why engineering is really cool. So engineering, in my opinion, even in and of itself, is problem solving. You're given a problem and you're meant to solve it. And the engineering curriculum, the engineering classes that you take, just teach you approaches to general problem solving. If you're a chemical engineer, you do problem solving with a little chemistry on the side. But we all sort of have the same basis in engineering for approaches to problem solving. And that makes you extremely versatile in your careers, because if you can know how to approach a problem, you can approach any type of problem, whether it's a chemical problem, an electrical problem, a mechanical problem, or not. What if it's a shipping problem? You use those same approaches, and therefore an engineering education makes you very versatile in industry. Oh, how did I get started? That's right. We started in high school. My physics teacher said, you're good in math and science. You should be an engineer. I said, okay, Mr. Weston knows. I said, hey, Ma, Mr. Weston says I should be an engineer. I'm good in math and science. And she said, oh, that's great. They make lots of money. Okay. All right, Mom, we love you, but we're glad for your support. When I went into college, then I found out there were different kinds of engineers and I had to pick one. I had no idea. So I went to the dean of the college and asked him which one did he, based on my what I'm doing well in and what I'm enjoying, which should I go into? And he said, oh, definitely chemical. Little did I know it was at the time when he had seen his chemical engineering numbers plummet from 100 in a class to about 20. But anyway, that's where I wound up. And I think it was a really great choice for me.
So now let's get on and talk about how you started your career. Tell us more about these roles and what were exactly involved in being a plant engineer, a process engineer, or functional support engineer.
Right. So working in the plant, the first 10 years is sort of building a foundation and learning about your industry and learning about how things work. And it's really setting the foundation for your career. And it's teaching you the basis of how do you approach a problem? What are some ground rules that you should always use? Coming in, a plant engineer is basically an engineer who works on the floor in a plant and supports. And now again, I'm talking pharma, so we're just going to limit it to that because that's my experience. Who supports the actual processing of chemicals to make a drug. So you're on the floor, you're standing, you're wearing safety glasses, you're wearing big, heavy safety shoes. Sometimes you have to suit up and put gloves on, and you really get hands-on. The first time they put a new tank in, you're the one that has to make sure it test it out and make sure everything works well. We had one tank where they put a valve in. There's a valve, it's called a check valve. And what it does is it only allows liquid to flow one way. And they had it in backwards. So we couldn't pump the tank out. And we couldn't figure out why we couldn't pump the tank out. The worst thing was this valve was about 20 feet up in the air on a pipeline. And it was February. So here I am in the middle of the night. I had to, we were working shifts. We support, when you're a plant engineer, you will work shifts. Had to shimmy up the ladder and crawl along the pipe until I found where the valve was installed backwards, make sure it was installed backwards. And then in the morning, we sent a mechanic up to change it out. So those are the kinds of things that you do as a plant engineer, but it's awesome. You not only do you build a foundation of understanding and the application of the engineering principles that you use, but you make friends that you keep forever. So setting your foundation as a plant engineer, that is really one of the best places that you can start. From there, you can take on some of the other roles. However, these other roles do hire new engineers directly out of college. All three of these roles that you see on the screen, you can be hired directly into. The plant engineer, the process engineer, and the functional support engineer. Let's
now talking about the next phase of somebody's career, using your career as an example. And you've always worked for Merck, haven't you?
I have. I used to say, I've worked for 32 years, but I started out when I was 10 because I wouldn't admit to anything over 40, but it's just not working anymore. So, but yeah, I started in 1989. So we're coming up on 32 years in June.
What role did you take? Perhaps you can talk about your roles in that phase and then the different options of roles that other individuals with different interests might pursue.
The best example that I can give you is, as you were talking about earlier, Dion, many times in order to make the most use of our facilities that we build and run and the overhead associated with them, we try to focus on the end of the process, of a chemical process in making a drug. The reason is that's where your biggest value is. When you have some of the earlier steps, the cost per kilogram of that material is far less than at the end. So what we would do is we would divide up our process into several pieces, and we would it's called outsourcing. So we would send that proprietary secret recipe to another chemical company to have them make that powder for us. make that one compound. And of course, there are all sorts of legal agreements for confidentiality and purchasing involved in that activity. So then if you have 2 or 3 different pieces that come in, then once we get all those pieces, then at Merck, we would combine all those pieces and make the final product. So that's what you were referring to earlier, Dion, and that is called outsourcing. And for about 8 years during the second phase of my career, I was a technical coordinator for outsourcing. I was the person between the chemist at Merck who knew how things were supposed to run, what it was supposed to look like. Was it supposed to turn yellow? No, it's really not. It's supposed to stay white. And the people making the drug in typically other companies such as China, India, and Europe is mostly where we sent our processes for outsourcing. And so I was the go-between between the two parties. So it was very helpful to have a knowledge of chemistry, a knowledge of processing equipment, so that I could translate between the chemist and the engineer in China, India, or Europe.
Joni, have you got any particular takeaway tips, thoughts of inspiration for the young aspirational engineer out there? Maybe they've just started their career in chemical engineering, maybe they're studying a chemical engineering course at college or university.
First of all, do it, right? Engineers, as I said in the beginning, engineering is an approach to problem solving. And you would be surprised how the approach that you learn in school applies so broadly throughout your life, and not even just for your career. When you're at home and you're trying to figure out how to do something, how to fix something, it applies even there. And as I had said, that engineering is broad. It gives you a great foundation at school for being able to apply knowledge that you gain in industry, and it gives you the opportunity to move into many different areas. You don't have to do chemical process design. You don't have to do plant design and plant build. You don't have to do engineering floor support. Just having an engineering degree allows you to go into consulting. It allows you to go into, as I had said, supply chain. It allows you to see logistics designs. So there's a lot of opportunity outside of the technical part of what you learn in engineering. Build your network. Having a network of people that you can always tap into is amazing. Being 30 years in the company, I can pick up a phone and call somebody who is very high up, who, hey, remember when we were sitting on the plane that almost crashed together, right? And to have those kinds of connections from when you were down in the trenches during your first 1 to 10 years is very beneficial. So build a network, don't burn bridges. I'm sure you wouldn't. But value your network and use your network, and don't be shy to call somebody and say, hey, can you give me a recommendation? I'm applying for this role in this other department. And I think if you talk to the manager, it would be really helpful. The biggest interview tip that I can give you is when you're asked a question, have you ever have you ever been on a team where you couldn't get everybody to agree? Instead of giving a vague answer saying, yes, we had this problem, be very specific. Say what the problem was, what you did, and what the solution was. Be very specific about your contributions to solving a problem, because that is what really sticks with people. Interviews are kind of all about you. Make sure you show that you understand what the company does, what you understand what the job does. And if you don't be shy to ask questions to clarify the responsibilities of the role. Because when you're in an interview, an interviewer is looking for a good match between what the role is and what you want to do and what you can do. And making sure that you understand what you're getting yourself into, so to speak, is very comforting to the interviewer. Like, oh, this person understands the role and they can do it. So those would be a couple of good tips.
Brilliant. Well, thank you so much. Do check out the playlist, look at the videos coming up. If you click the reminder bell, you will get a notification of when we go live so that you can join those. all of the Drive Live with an Engineer sessions are available on demand afterwards, so you can go back and watch those, share them with your friends and your colleagues, etc., so that they can get some value from this as well. Thanks so much, Joni. I look forward to catching
Thank you, everybody.
again in the future. It's been a fascinating discussion, and I wish you a fantastic 2021.
Thank you.
Thank you.
Good day, everybody.
Goodbye.